I'm going to start recording in progress. So I'm going to share my screen and let's just start with the class. If more people join, I'll check. So hello everyone. My name is Ayush Prasad and welcome to the next class of C Programming 101, the introductory session about C. This is from Ayush Prasad for the Funtastic Academy. I already given my introduction about myself. I'm Ayush Prasad. I run a YouTube channel called the Funtastic Academy where I explain about science, and this is my class about programming. So these are the ground rules. We covered this last class. I touched some bases. So let's go to the what we're actually going to talk about today. This is introductory class. We'll talk about control flow, how to decide things when things happen. We're going to talk about loops, repeating stuff. We're going to do advanced arithmetic and conversions. And finally, we're going to use symbolic constants to make everything we do a little bit easier. So, this is our first programming challenge. So, Havish, can you just read out what's on the screen?
Challenge 1 GPA calculator. Specifications must take a grade from 0 to 100 and output a GPA from this chart.
Got it. So, given the grade, you must output the GPA. Now, how to input the grade is a complicated thing because, as I said, C's handling of input and output is quite weird. So, we'll just assume we have a variable x, it's a float, it shows a grade from 0 to 100. How do you convert this to a GPA according to this chart? So, Havish, what are your first thoughts on how to do this in online GDB?
I don't have any idea about it.
Okay, well, that's nice. We can start exploring. So, first off, obviously, we take an input. Let's say we have a float grade, float in decimal. It's coming out of nowhere, and it's equal to this. So this is our grade. It's a decimal value, and we are declaring it. Now, the way we calculate the grade initially is using something called an if statement. If statements are simple. If the thing inside the brackets are true, it will do a thing. And the thing is in these braces. If this condition is do, then do an activity. This is how if statements work. For example, if we look back to this chart, if the grade, if it is between 0 and 59, output 0. So what we write is if grade is less than 60, then printf, print out the value 0. And this will solve our problem, right? What we can do is we can chain these statements together. We can use an else statement. The else statement. Do you know what if else statements, Havish?
Yes, I know.
Great. So now we can just simply write else if grade is not less than 60. If the grade is not less than 60, but it is less than 70, what do we do? What value do we return?
1.
Correct. Now we will use the programmer's most important skill, the skill that is most vital in time that you have to program. What is the vital skill? Knowing how to use Control C, Control V, Control V, Control V. So we just alter these statements for all the other values. Printf GPA of 2 or 3 or 4. And now if we run it, it fails. This leads to some issues, right? This code is quite messy, it's disorganized, you have no idea what it's supposed to do. We can do some indentation, of course, but what we have to do is add the if conditions. We actually miss the else if conditions. We fill in these conditions. This is a problem, right? You sometimes forget critical statements like this and leads to bugs. But if we do this, it outputs GPA 4. Correct. Now, can you think of a simpler way to do this? Harish,
Yes.
can you think of a simpler way to do this with only using one if statement?
One if statement. Others must be else only. Actually.
No,
Actually,
only using one only using one condition. One if, zero else if, zero else statement, zero switches. Can you think of a way to solve this problem?
after grade less than 70, we have to keep that one symbol. It is required there. It is expecting.
Yeah, the curly braces, right?
Yes.
I don't think you understand French. Can you do this with only one if statement? Here we use five. We use five statements. Can you do it with only one if statement?
It is not possible.
There is actually a very silly way to do this using each programmer's greatest fear, mathematics. See, what you notice about these numbers 60, 70, 80, and 90.
What?
Do you notice anything about these numbers 60, 70, 80, 90?
Yes.
What?
They are integers.
Anything else?
Hmm?
Anything else?
Their numbers.
Anything else?
Anything else I couldn't.
60, 70, 80, 90.
I couldn't find it.
They're in an arithmetic progression. Every step they're increasing by 10 now.
Hmm?
These all numbers are in an arithmetic progression. Every step they increase by 10, right?
Hmm. Yes, it is increased by 10.
Yeah, and all of these numbers, every step they increase by 1. We have
Yes.
two arithmetic progressions. So we can easily change one to another with a little bit of algebra. So what we have to do, we just, how to use algebra, how to use math in C. Hashtag include math. Well, that was a joke. You don't have to use math. There's one function in math that we will be using. So what we can do is set grade equal to grade minus grade equal to grade minus 60. And there's a simpler way to write this. You know how to shorten the statement grade equal grade minus 60?
I don't know.
See, whenever in C you have something equal x equals x and then some operation, then something, you can shorten it as x operation equals something. Example, x equal x plus 2. You can shorten this to x equal x plus 2. You can shorten it to, sensitivity, you can shorten to x plus equal to 2. Understood? Understood?
Okay.
So we can shorten grade equal grade minus 60 to grade minus equal 60. Similarly, if we wanted to divide by 10, what we use is grade divide equal 10. Now this is one if statement only. If grade less than 0, grade equal to 0. Now, we have done a linear map. You know what that is? A linear map?
No, I don't know.
Okay, it's something that you are going to learn in your mathematics classes. We have converted 60 into 1, 70 into 2, 80 into 3, and 90 into 4. And we have mapped the numbers like this. We have made a conversion. A conversion is also known as a map. Now, 60 is 1. If our grade is 60, then 1 will then 1 might come out the other end. But how do we actually get out the values we need? Well, in math.h, there's a function called ceiling. And and there's another function called floor. And both of these will round the number you have. Ceiling will round it up. Floor will round it down. Let's say we have the grade 61. We're subtracting 60, so it'll become 1. We're dividing by 10, so it becomes 0.1. We have to round this number up so that it will become the number we want, which is 1. We need to round 0.1 up to 1. And we use the ceiling function. Ceiling is defined in mathematics. So grade equal the ceiling of grade. Understood?
Understood.
And we print out grade. And you know how to print a number? You know how to print a value?
Quotation mark.
We write percent point 0 comma grade. What does this mean? Percent point 0f?
Can you say?
What does this mean? Percent point 0f.
I don't know.
What does it mean? See, percent means you're gonna insert the value here. Percent means value. Then f means a float, a decimal. We are printing a decimal number. 0.0 means skip all the decimals and just print the value itself. We won it. And there was a missing semicolon. We run it again and we get the GPA 4, which is correct answer here. But if we change the GPA a bit, we should get a lower value here. We get 0. So this is our GPA calculator. Now the version 2. It is much faster than our original version. Because on computers, if statements are extremely slow, but doing math is really fast. So all of this stuff here is math and only one if statement. This makes it really fast. Understood?
Understood.
Got it. So this is our first challenge, the GPA calculator. And we learned control flow, how to do if statements, that's called control flow. And we learned advanced arithmetic, the ceiling function. That will help us in doing mathematics better. So so we sped up our control flow with mathematical calculations. Now, this is the second challenge, Fahrenheit and Celsius conversion. Okay, so can you read the specifications quickly off here?
Must give degree Celsius conversions of degree Fahrenheit temperatures from minus 40 degree to 140 degree Fahrenheit in 10-degree intervals.
So you know the formula for converting Celsius into Fahrenheit?
I forgot a little bit.
Fahrenheit to Celsius? Well, if you forgot, don't blame me. No one remembers, even I barely remember. But the Celsius of a Fahrenheit is equal to Fahrenheit minus 32 multiplied by pi over 9. So what we could do is just use a while loop. You know what while loops are?
Hmm?
You know what while loops are?
No, I don't know.
So a while loop will keep on repeating what you do as long as the condition is true. Let's say
Oh,
we have a variable int f, and that is equal to minus 40. And we also declare a float a decimal value c, but we don't declare it anything. While f is while f is less than or equal to 140. This will loop until f is 140, at which point it will stop. While f is less than or equal to 140, at each step we need to increase it in 10-degree intervals, right? So what we can write is f plus equal 10. This will give us the interval. Now the actual calculation. We can say c equal to f minus 32 multiplied by 5.0 divided by 9.0. You know why we have point zeros here? Why we included point zero?
don't know.
See, there's what's something called division truncation, which is a fancy way for having no idea how to do division. If we give it integer values, 5 over 9, it will automatically round down the values according to the C language, which is one of the most advanced languages used for years by many professional developers. 5 over 9 equal to 0. So we have to write 5.0 over 9.0 so that we get full results. Understood?
Yes, I understood.
So now we have our Celsius. We convert it and we printf the results. So we have to do some pretty advanced printing over here. What we can do is we do percent d space percent f, and the f has to be formatted in a way. Let's say the f is formatted 3.1. What this will do is print the Fahrenheit in the first bracket and print the Celsius here. And the Celsius will have 3 gaps of spacing and 1 and a 0.1 decimal place. What happens when you run it? Oops, we get all this spill. Why do we get this spill? Havish, why do we get all these spillage of the results?
We have used intervals. We have used intervals to get this degrees.
No. Why are the results coming like this? All just in one line?
Oh, okay.
Because we forgot to put enter. We forgot to put the enter new line key. So we have to use the code word in C for a new line. New line is read by an escape character. You know what's an escape character?
Hmm?
You know what is an escape character?
No, I don't know.
Is like an escape character is like a code for a particular thing. For example, the escape character \n. It's a code for taking a new line or enter. So now I'll enter and get a new line every time the conversions are finished. And the results come out beautifully like this. You see?
Yes, I see.
Yeah. So this is how we can use escape characters. Now I'll just remove this math dash because it's not helping us at all. So can you just give us a quick summary of what all this code does, line by line?
First one we are giving integer value as f is equal to minus 40.
Yes. Next line.
Next we are next we are saying that C is a float.
Next.
Next we are getting repeated. We are getting that f given value minus 40 repeatedly coming till it reaches 140.
Yes. Next.
Next we are converting into Celsius. We are using the formula f minus 32 into 5 by 9. That
Amazing. Next.
next we need to know the values what we get from the above line. So we are using the print command and we are using that percentage d space percentage 3.1 f slash n quotation comma f and c. We are inserting that f and c to be printed.
And finally,
We are giving the intervals value.
amazing. But there's a much quicker way to do this in much shorter line of code. Do you know how?
No, I don't know.
We use a for statement. For is essentially all the looping behavior, which does a repeated thing, packaged together in an Amazon package for the one line. So in this once line, we can declare int f equal to minus 40. In this one line also, we can declare that we have to keep on repeating until f is f while f is not equal to 140, and on each iteration we have to change f by 10. All the looping behavior packaged into one statement. Did you see this?
As I see.
And also, there's no need to have a separate variable for c that creates the space. We can actually compute it directly in the printf command. We can have the same thing inside the command. Percent %d, percent, I'll give extra space to the float now, 6.1f \n. F, and then we have the conversion f minus 32 times 5.0 by 9.0. We run this and it gives the same results. But can you see what's the one problem with this statement? One problem.
What problem?
Problem is no one understands what is this. What are these numbers? Why is this? How is this? If you're working in Google, Microsoft, you're making C code, you show this to your coworker. Hey, I made this line of code. His immediate questions would be, what is this number? Why is this number? How is this number? So, can you think of a better way of making writing these numbers?
Mm,
We use something called a symbolic constant. Essentially, it's like a variable but different. We can define a symbolic constant. We hashtag define it. We define, let's say, the lower limit of the loop to be minus 40. And now,
cool.
and now we can here write lower and use the number lower in its calculations and works out the same. Similarly, we define the upper limit of the loop to be 140, and each step we take a step of 10. Now, it appears that someone else has joined the waiting room.
Upper.
So I'll admit someone new to the waiting room. Uh, Sanjay, hello. Hello, Sanjay, are you there?
Yes, I can hear you.
Sanjay, hello. Sanjay, hello. So I'll just wait for Sanjay to unmute, then we can talk more. But for now, I'll just give a quick summary of it. So we've defined the lower limit of the loop to be minus 40, the upper limit to be 140, and every time we take a 10-degree step. Then we declare an int f to be the lower limit, and as long as it's less than or equal to the upper limit, we keep on increasing by step and do this. And here we have the conversion, nicely packaged into only these few lines of code. Understood?
Yes, okay.
So, what did we do in this class? We learned about arithmetic, we learned loops, and we learned about symbolic constants. Understood? Havish, yes?
I have one doubt.
Yes?
In line 16, printf, you have used after comma f comma, you have used the calculation for Celsius, right?
Yes.
Okay, okay.
So, so now what we're going to do is I'm just going I'm just going to lay the groundwork of something we'll discuss more in the next class, right? Because some of you missed the last class and we still have some time, right? We're going to talk about a new topic that we'll cover more in depth in the next class. Got it?
Got it.
So you know what are arrays. Havish, do you know what an array is?
No, I don't know about arrays.
Do you know what Python is? You know Python?
Yes.
Okay, because Python has arrays on another name. In Python, what you would call a list. In C, we call that an array. An array is just a list of things. But the difference is in C, lists are ve- in C, lists are very arrays are very finicky. In C, arrays can only have one size. Once they are declared, they can only have that one size forever, and you can never change that size. Got it?
Got it.
So, so here's just a quick program you can write using an array. Print everything in a list. What we can do is we set our array ARR, and it's of type integer array. So we can make an integer array of R. R is an array, which we indicate with square brackets. And then we can set it to a constant, just some random elements 2, 7, 3, 8, 11, and so on. Now, how do you calculate the length of an array in C? Do you know, Havish?
I don't.
See, in Python, you can just use array name dot length. In C, there is no length operator, but there's this thing called size of. Size of will tell you how much space in the actual computer this entire thing is getting in bytes. Then we use size of to calculate how much space each of these numbers is taking. We divide and we get how many bytes are in the entire thing. Havish, what is your question?
Next value, what will be you will be entering?
This array we cannot add the next value because the size always remain the same. Like this is a quick program to print out the elements. What we can do is set the length of the array. It's just equal to the size of the entire array divided by the size of each individual element, each int. What happens if we run this? It does nothing. That's good. There are no errors so far. So we just make a print routine. We declare an integer to be 0, and while it is less than the length limit, we address it like a list in Python. You know how to address lists in Python, right? We just write I equal to I plus 1. Or for short, you can write this as I plus plus. This will increase by 1. I plus plus. Understood?
Okay.
So for each I in the list, we just printf the number. Okay? So percentage D and percentage D, and then we write the element of the list. So R I. This will print all the numbers out. Got it? We have this function to print all the elements of an array. Understood?
That's understood. Slash n means
Enter new line. So we're
oh,
printing a number and then hitting enter key to get into a new line.
okay.
Now, now what we can do is we can we can talk about ideas. We'll actually start coding more about arrays, learning how to implement these algorithms in C later on here. But now we can just think about just algorithms. Like, for example, how would you reverse print the elements of an array? How would you reverse print them?
We want to change the arrays like 2 should go back, 11 should come front, 11,
Yeah.
8,
Yes.
3, 7, 2. We should print like that.
Yes.
11, comma, 8, comma, 3, comma, 7, comma, 2, comma.
Yeah. Yeah. We can just get the values in reverse. So we start at the maximum, the whole length we start there. And while it is greater than or equal to 0, we want this. And oops, there seems to be some errors. Reason is we turned out to be accessing some wrong values in memory. This is called a memory leak. And it's a complicated subject, which can happen when you change the size of an array. It's a really complicated subject. We'll discuss it later. So we have to decrease the I. That's the problem we ran into. We have to decrease I and print it the wrong way. And now we have the result, a reverse print. Got it?
Got it.
Now, similarly, we can do operations such as printing every other element. And the way we can do that is and this will print every odd number element. But if we change it to this, it will print every even number element. Got it?
We have to change that integer I is equal to 1 or 2. That like,
Yeah,
oh,
I is equal to 0. It will start at 0, then print element 0, element 2, element 4, and so on. If I equal to 1, it will print 1, 3, and so on. So we can flip between odd and even by just changing this I. Got it?
got it.
So we now know how to handle arrays in C. Now, my challenge for you is this. By tomorrow's class, which is happening at the same time, can you come up with a good idea, not a program, but an idea of a program to do something cool with an array? Then tomorrow we can discuss on how to actually write that in C. समझ गया? Havish, समझ
What?
गया? My
I
challenge,
couldn't hear you.
my challenge for you is this. By tomorrow, just come up with an idea of an algorithm to do something cool with an array. Like to sort the array or to give the numbers in every third element, but sometimes it repeats. Just come up with an algorithm to do something cool with an array, like sorted, for instance.
Okay.
Idea of an algorithm, not any actual code. Actual code,
Okay.
we'll discuss in next class. Got it?
Okay. Tomorrow I will come with it.
Understood. So in future classes, we're
Yes.
going to just discuss more about input output and about functions and how we can use functions to make code neater. And the kind of class is going to be tomorrow on the 14th April. After that, we'll have more advanced topics in a future course. And just reminder, all your proceeds and fees from this class is going to Nachiketa Tapavan, a NGO1 school in Telangana. You can donate and contribute to this school as your wishes. And remember, every time you donate, you are helping a life get out of poverty and rise up in their life. So thanks, Havish and Sanjay, for attending my class. Thank you all so much for coming when so many other people chose not to come. And I hope you see you tomorrow. Bye.
Bye.